The Big Bang illuminates a dark, empty limbo, and an entire universe appears. It expands incredibly quickly. Within a second of the explosion, energy shatters, creating forces like electromagnetism and gravity. All the matter in the universe explodes from a single point.
This just in. Everything exploded, and now it exists.
At first, scorching temperatures from the explosion prevents the matter from being organized, but after a couple of seconds, temperatures have fallen low enough for protons, positively charged particles, to link up with electrons, negatively charged particles. Together, they produce electrically neutral atoms, simple ones like hydrogen. Then hydrogen atoms collide with one another in a nuclear reaction, thus resulting in nucleosynthesis. Helium emerges, and soon the universe contains vast clouds of these atoms. The clouds are essentially mush, but contain within them tiny differences in density that allow gravity to compact them. The early universe breaks up into a billion clouds whose density and temperature is constantly increasing.
Hydrogen atoms are slamming into each other at every which way. It's creating helium. This is called nucleosynthesis.
Here's what happened next. Wherever there was slightly more matter, gravity was more powerful. Soon, gravity packed slightly denser regions closer together, squashing them so tightly that they began to heat up. Eventually, the clouds got so hot that protons and electrons split apart once more. Then, when temperatures in these hot spots grew to be about 10 million degrees Celsius, protons began to fuse together and part of them turned into energy in the process. This huge release of heat from the center of each cloud of matter stopped the cloud from collapsing any further, and 5 billion years later, after the Big Bang, stars are born. Each star would continue releasing energy into space for millions or even billions of years until it had no more protons to fuse. Through nucleosynthesis, only elements up until iron could be produced. As these stars formed, so did galaxies, each containing billions of stars.
Gravity's pulling huge clouds of helium and hydrogen together, and the temperatures are getting so hot, and protons are fusing, and stars are being born.
Up until this moment, the universe consisted almost entirely of two types of atomic matter, hydrogen and helium. These were like gases, except one of them was totally inert. Thus, it was impossible to make anything interesting. That was why the universe needed more elements. Making new elements meant fusing more protons and neutrons together. To do that, you need very high temperatures, which could only be found in massive stars. Only they have the right conditions to form more chemical elements. Why? Well, large stars have so much mass, allowing them to create enormous pressures and temperatures. Those temperatures get cranked even higher when the large stars run out of hydrogen. In addition, the inwards force of gravity further risks the possibility of the star collapsing. When that happens, fusion stops at the center and the star collapses. If the star is big enough, the collapse is huge, creating such high temperatures that helium nuclei can form into nuclei of carbon. When the star has used up all its helium, it collapses again, and the cycle starts all over, each time creating new elements like oxygen, silicon, and even iron. In other conditions, like particularly large stars, a supernova will occur. That's an explosion so hot and so energetic that for a while it will shine like an entire galaxy, and it will produce enough heat to form the other elements. Then, the supernova scatters these elements into space, liberating them from the stars.
Stars are collapsing. That's a black hole. Stars are exploding. That's a supernova. The chemical reactions are occurring. That's when an electron goes from one element to another, and more elements are born.
After a while, chemical reactions take place where a rearrangement of electrons occurs. This is different from the nuclear reactions that take place within the first 3 minutes of the Big Bang. This is because the chemical reactions do not involve changes in the nuclei. In the end, we have a universe of all these different elements. These elements combine to form chemically complex planets and moons, and our solar system is born.
That's our latest development in this 15 billion year story. See you next time. This has been kailor. Some Swedish scientists just created ununium reactions. That's when no. Okay. Gravity's pulling the. Okay. Show it again.